Now let us do the qualitative analysis of organic compounds. In this, we try to find out what all are the elements which are present in an organic compound. Now in this, we know that organic compounds basically are either hydrocarbons or are derivatives of hydrocarbons. So the first thing we do is that we do the testing or detection of carbon and hydrogen. So we will first do the detection of carbon and hydrogen, which is very easy. Now in this case, what is done is an organic compound is heated with cupric oxide. When it is heated with cupric oxide, we know that what happens is all of the carbon of the compound combines with cupric oxide and the cupric oxide gets reduced to copper and the carbon gets oxidized to carbon dioxide. So whatever the fumes which are coming out are allowed to pass through this lime water, which absorbs the CO2 and gets converted into CaCO3 and H2O, and this is how it becomes milky. So if the lime water turns milky, it means the compound which we are having is having carbon. Also, the hydrogen of the organic compound, which is there from the organic compound, and this is also there from the organic compound, when heated with cupric oxide, gets oxidized to what we know that gets changed to water, and the copper gets reduced. And where this water is allowed to move out, since we are heating it, it is there in the form of vapors. Then this water is actually being absorbed by this anhydrous copper sulfate, which gets converted to 5H2O, and it becomes blue. So this is what we have. So once this becomes blue and we get milky lime water, it shows that we are having carbon and hydrogen in the organic compound. Now let us understand the detection of the other elements. For detection of the other elements, we perform a test which is called lecithins test. In this, organic compound is heated with sodium in a fusion tube. It is heated to red hotness, and then that fusion tube is broken down in a china dish which is having some water. Now what happens is, whatever the reaction which has taken place between sodium and the organic compound, now that compound which is being formed on that due to that reaction are now in the form of their aqueous solution. We filter out that solution, and that solution is called lecithins extract. We call it Le. Now let us do. Now we do all those tests to test the presence of the different elements on that particular extract only. And let us do the first detection of nitrogen. We know this, when the sodium is heated with an organic compound, definitely that is having carbon, and nitrogen is there. If it is there in that organic compound, sodium cyanide is formed. So this is there in your lecithins extract. Now that lecithins extract is taken and a freshly prepared ferrous sulfate is added. It has to be freshly prepared so that there is no oxidation. Then what we do is, we can do two things. We can add either ferric chloride, or what we can do is we can heat the reaction mixture with sulfuric acid. Now what happens is, if you are adding ferric chloride, we are providing the ferric ions, or if we are heating it with sulfuric acid, few of the ferrous gets oxidized to ferric ions, and what we get is, we get a Persian blue color. So the appearance of the Persian blue color indicates that the nitrogen is there in the organic compound. Now what all reaction takes place is, since the cyanide is there and we have added ferrous ions, what happens is we get ferrocyanide. This is the ferrocyanide we get in the solution. Now when this ferric ions are provided either by adding ferric chloride or by oxidizing them with sulfuric acid, what happens is these ferric ions combines with this ferrocyanide ion, and it forms ferrocyanide. This is 3, this is 2, which is actually is blue in color. And this is how we detect nitrogen. Now let us do the detection of sulfur. See, once we have a sulfur in the organic compound, sodium combines with the sulfur and we are having actually sodium sulfide in the solution. Now this sodium sulfide solution we know that it is there in the sodium your lecithins extract. So what we do is, there are two tests of sulfurs. We take lecithins extract, we add small quantity of acetic acid to this, and then we add lead acetate solution. If we get a black PPT, black PPT, sulfur is confirmed. How this happens is, see, we have a sulfide ions and we providing them what lead ions. They both combine to form lead sulfide, which is actually is black in color. That's one of the methods. The second method is called sodium nitroprusside test. Now what we do in this case is, when we add sodium nitroprusside to the the lecithins extract, which is actually is FeCN5NO2 minus, they both combine and we get this complex 4 minus, which is violet in color. So if we get violet coloration on adding sodium nitroprusside to the lecithins extract, this again confirms sulfur. There's one problem in this. If suppose sodium, the nitrogen and sulfur both are present, remember, when nitrogen and sulfur both are present together in the organic compound, thiocyanide, sodium thiocyanide is formed. Now this sodium thionate solution, so this is there in your lecithins extract. So when we were doing the detection of nitrogen, in that case, the ferric ions combines with this thiocyanate ion and they form what? This CNS. Ferric thiocyanide, or if we can have this one in this ferric thiocyanide, which is actually is blood red in color. So if this is formed, we have what? Nitrogen and sulfur both existing together. Now let us do the detection of halogens. What we do is we take the lecithins extract and to this we add small amount of nitric acid followed by silver nitrate. We get precipitates, of course, and that precipitate colors tells us which halogen we are having. We need to know this. What happens is, like if we are having chlorine, what we have got is sodium chloride. If we are having bromine, we could have got actually sodium bromide. And if we are having iodine in the organic compound, iodine, we would have got sodium iodide. Now the moment we take this silver ions, what happens is it can combine with the chloride ion to form AgCl. So we get white precipitates. If we are having what bromide ions in the lecithins extract, we will get AgBr. What we will get is pale yellow precipitates. And if we are having what iodide ions, then what we will get what AgI as dark yellow precipitates. So these easily tells us which halogen is there in the organic compound. Detection of phosphorus. Detection of phosphorus is done separately. It's not done by the lecithins test. What we do is that the organic compound is heated with sodium peroxide, the oxidizing agent, which oxidizes all the phosphorus of the organic compound to phosphate ion. Then the mixture is heated with nitric acid and actually it is being boiled with nitric acid, and then ammonium molybdenate is added, which gives yellow precipitates. So once we get yellow precipitate, it confirms what? The presence of phosphorus. Now what all reactions takes place is that when the organic compound is heated with this peroxidizing agent, we get phosphate. So in the reaction mixture, we are having like the sodium phosphate, we are having because phosphate ions mainly. Then when these phosphate ions are heated with nitric acid, what we get is phosphoric acid. That phosphate ions converted into acid called phosphoric acid. Now this phosphoric acid combines with ammonium molybdenate, which is NH4 twice MOO4 ammonium molybdenate in presence of nitric acid. And then what we get is ammonium phosphomolybdenate, which is actually yellow in color. So this is the compound which we get as a yellow precipitate or yellow coloration along with ammonium nitrate and water. And this is what we have. We can detect the phosphorus in the organic compounds. Now let us do the quantitative analysis. After detecting the different types of elements which are there in a given organic compound, we will try to find out their percentage composition, so that we can move on to find out their empirical and molecular formulas. And in this process, the first to go is the method of finding out the percentage of carbon and hydrogen. In this, what we do is we heat organic compound with obviously again the same thing, the cupric oxide. We'll again put copper gauge actually like this, so that the other substances gets easily being reduced. Now when we heat this, we know that all of the carbon gets converted into, with cupric oxide gets converted into CO2, and hydrogen gets converted into water. The CO2 and the H2O formed are allowed to pass through these two types of U tubes, which are having calcium chloride, anhydrous calcium chloride, and potassium hydroxide solution. Now what is most important to note is that we weight these U tubes initially, and then after passing the CO2 and H2 which are coming out from the organic compound completely, we again weigh them, and the difference of the weight of these U tubes tells us that how much of the CO2 and H2 are being produced by heating of a given amount of an organic compound. Now we must know this, that a whole of the water will be absorbed by the calcium chloride, and whole of the CO2 will be absorbed by the potassium hydroxide solution. So by finding out the change in the mass of the U tube of the calcium chloride, anhydrous calcium chloride U tube, they can find out the mass of the water produced, and by finding out the difference of the weight of the U tube of the potassium hydroxide, we can find out the mass of the CO2 produced. Now once we know the mass of the CO2 produced and we know the mass of the organic compound taken, the percentage, and we know that since the carbon and hydrogen, they always oxidizes to produce CO2 and H2O by this equation, percentage of carbon will be, since we know that in CO2 out of 44, 12 is carbon, so 12 by 44 into weight of the CO2 upon weight of the organic compound into 100 will give us the percentage of carbon. In a very similar way, if we want to find out the percentage of hydrogen, it will be in water. We know that water is 18. There are two hydrogens. So weight, so 2 upon 18 into weight of water formed upon weight of the organic compound into 100 will give us the percentage of hydrogen in the organic compound. Now let us do the detection of the estimation of nitrogen. The estimation of nitrogen is done by mainly two methods. The first one is called Dumas method. In this, what we do is we heat the organic compound in presence of cupric oxide. Small amount of copper is always there because whatever the small amount of nitrogen oxides are formed, they are being reduced back to the nitrogen. So we know that if we are having an organic compound which is having carbon, hydrogen and nitrogen, heated with cupric oxide, we get CO2 and H2O and the nitrogen gas. This nitrogen gas obtained is collected by downward displacement of water, and from there we can know the volume of N2 produced from the given amount of this organic substance, and this volume of the N2 produced is changed to what? STP, volume at STP, by using the formula P1 V1 over T1 is equal to P2 V2 over T2. So we can find out the volume at STP, and then we know that since this nitrogen is 28, its molar mass is 28 grams per mole, and it is obtained by, and its 1 mole is having the how much of volume? 22,400 ml is the volume. So we can find out the percentage of nitrogen as 28 upon 22,400 into volume of nitrogen at STP upon the mass of the organic compound in 200. So this gives us what? The percentage of nitrogen in the organic compound. The next method of finding out the percentage of nitrogen in the organic compound is called Zelda's method. In this method, the organic compound is heated with concentrated sulfuric acid so that the whole of the nitrogen gets converted into what? It's nitrogen salt, ammonium sulfate. Now that salt, when heated with NaOH, we know that will produce ammonia. Whole of the nitrogen gets converted into ammonia. Now this ammonia, which is given out in the form of fumes, along with we have sodium sulfate and water, this ammonia comes out in the form of fumes or vapors, and this ammonia is actually being titrated with known amount of sulfuric acid. The sulfuric acid gets neutralized. Now the whole of the nitrogen which is there in the organic compound is converted into what? Ammonia, and the whole of the ammonia is passed through this sulfuric acid, and the excess of the sulfuric acid left out is back titrated with the known volume of known concentration of NaOH, and this is how what we can find out the exactly amount of the sulfuric acid which is being used for the ammonia. And from there we can find out the percentage of nitrogen as 1.4 into m into 2 into V minus V1 by 2 upon the mass of the organic compound. See what is there where this m is? M is the molarity of the sulfuric acid used, and V is the volume of the sulfuric acid used actually taken to titrate this ammonia. Now out of this, the excess which is of the sulfuric acid left out is being titrated with the known amount of the NaOH solution, whose molarity again is taken as m, But the volume of the Na which used to titrate against with the excess of the sulfuric acid is V1. So when we minus V1, we will get exactly the volume of the sulfuric acid which is used for ammonia. Why I am dividing it by 2? Because there is a difference of the N factor. Sulfuric acid gives 2H plus ions, and ammonium sodium hydroxide is only having N factor 1. So that is how we can find out the percentage of the nitrogen in the organic compound by this Zeldha's method. Now let us do the detection of halogens. It's done by a method called Carious method, in which the halogen is taken along with the fuming nitric acid and silver nitrate and heated in a closed glass tube which is called Carious tube. What happens is the whole of the carbon and hydrogen gets oxidized to CO2 and H2O by fuming nitric acid, and which is being separated out. And the halogens which are there in the compound reacts with the silver nitrate, and they get precipitated out either in the form of AgCl, or in the form of AgBr, or in the form of what we can have is AgI. Now we can now those precipitates are taken out, washed and dried, and from there we can find out the mass of the AgCl, mass of AgBr, and mass of the AgI produced from the given amount of the organic compound. And from there we can find out the percentage of chlorine. Like in AgCl, we know that chlorine is 35.5, and the total mass of AgCl, because chlorine is 35.5 and silver is 108, makes it 143.5. So percentage of chlorine is 35.5 upon 143.5 into mass of the AgCl produced upon mass of organic compound into 100. In a very similar way, the percentage of bromine will be 80 upon 188, because bromine is 80 and silver is 108. So into what? Mass of AgBr upon mass of organic compound into 100. And similarly, the percentage of iodine will be 127 upon 235 into what? Mass of AgI upon mass of organic compound into 100. The reason being because iodine is 127. Now let us do the detection or estimation of sulfur. The sulfur's estimation is again done by the same method called Carious method, in which the compound is actually taken with fuming nitric acid, or we can take sodium peroxide. It is heated strongly so that the whole of the sulfur gets converted into sulfate, and that sulfate is being precipitated out as barium chloride by treating it with excess of barium chloride solution. So whole of the sulfur gets precipitated out in the form of barium sulfate, which is being separated out, dried, and its weight is mass is being determined. So the percentage of sulfur we can have is 32 out of the 233, which is the mass of the barium sulfate, into mass of barium sulfate upon mass of organic compound into 100. Now let us do the estimation of phosphorus. The phosphorus can be estimated by heating organic compound with fuming nitric acid, which converts all the phosphorus to the phosphate, which is then being precipitated out by reacting it with ammonium molybdenate, and the phosphate ion is precipitated out in the form of ammonium phosphomolybdenate. Now we can find out the mass of these precipitates. So the percentage of phosphorus will be 31, because this compound contains only one phosphorus, and whole of the mass of this ammonium phosphomolybdenate is 1877 into what? Mass of ammonium phosphomolybdenate upon mass of organic compound into 100 will give us percentage of phosphorus. There is one more way of doing it. In this, what we do is we treat this phosphate and whatever it is formed with magnesia mixture. So when we treat it with magnesia mixture, what we get is we get this ammonia precipitating out in the form of this magnesium ammonium phosphate, which is ignited to give magnesium pyrophosphate Mg2P2O7. They can find out the mass of magnesium pyrophosphate. So the percentage of phosphorus in this case, if we are doing it by this method, will be, there are two phosphorus, so it will become 62. Mass of this pyrophosphate is 222 into what? Mass of magnesium pyrophosphate upon mass of organic compound into 100. So this is how we can find out phosphorus. Now let us do the estimation of oxygen. See, we don't have any as such method of finding out the percentage of oxygen in an organic compound, what we do is we first find out the percentage of all of the rest of the elements, and if you find that the sum is not coming out to be 100, then remember the difference amount of the percentage is always the percentage of oxygen, because oxygen gets readily combined with everything and we cannot find out exactly where the oxygen of the compound is going. So after finding out the percentages or estimation of all the rest of the elements which are there in the organic compound and subtracting it by 100, the difference amount is the percentage of oxygen in the organic compound.